So we've been researching MikroTik routers for basically the whole of 2017, and 2017 is coming to an end. So we have a couple of presentations lined up. One of them is here, and this specific presentation is going to be about the tools that we've created, the tools that we found, and that we use to work with MikroTik routers. And we invite everybody to use them, to research their security, to achieve interoperability with some other tools that you like to install on your routers. So yeah, let's go right ahead. So first of all, any of you heard of MikroTik before? Okay, so we have approximately 30% of the auditorium filled here, so I guess the other ones just aren't here. Everyone has heard of MikroTik. Anyway, as you know, MikroTik is actually used quite widely. It's of course not Juniper or Cisco yet, but they're growing quite fast. So it's used all over the world. And Router S is their operating system that they use on their routers. It is basically Linux. It has a Linux kernel. By the way, the Linux kernel in the current MikroTik is quite an old one, so it's more than 5 years old. A good question to ask here is, do they actually apply the patches for the Linux kernel, the ones that come out, have come out through these 5 years, right? It's not only Linux, of course. It also includes startup scripts, Nova binaries, and your configuration. Now, the middle two of those, the startup scripts and the binaries, those are completely proprietary, which means that Router S is, of course, not only Linux, but it's also closed source and closed ecosystem. So closed source, we can deal with that. We've been there before. But closed ecosystem, not unlike Apple, we need a jailbreak to be able to properly work with these devices and to research them. So luckily for us, 12 years ago, when Router S 2.9.8 came out, they included a built-in backdoor, which was very nice of them. It works like that. So in /nova/bin/login, which is one of the binaries there, there is a string. It appeared at the end of 2005. Nova etc devel login. So what actually happens if you create a file, an inode to be precise, at that location, then this is what happens upon login. So the login binary actually checks if there's this file, nova etc devel login, and if you're logging in with username devel, and the password matches the admin password, you get bin ash executed and given to you instead of your standard very limited shell.
The answer we're all seeking.
Sorry. So the question, of course, is how do we make the file there? So it's quite easy. So one of my favorite comedians and musicians, Hillary, can talk instead of me here.
The answer we're all seeking is staring us right in the face. All we gotta do is.
So basically, it's as easy as creating the file, then you telnet, and you got your shell, right? Well, nowadays they don't really have hard drives in these. They have flash chips, so you can take it apart. You can easily mount it, but it's a bit too complicated, and there are easier ways to do it. After you get the shell, of course, you can't really do too much because there's no ls command, but it's well known that they have somehow managed to enable bash completion there. So if you press tab, for example, you type cat space tab, you get the list of the files in the folder. Or you can actually upload your own busybox after you routed the machine. The question, of course, is how do you do that? We presented a way to do it a couple of months ago. Now, in this presentation, I call it the old way because, well, we made the better way. Okay, let me show you a quick demo of how the old way looks. It's a VirtualBox appliance. I will start it up. Okay. So it is quite easy to use relatively to reflashing your chips. Basically, you answer the questions, right? In this case, we can say yes. The cool thing about the appliance is if you say no, it actually shows you the password. You can download that online. Okay, so then you plug in it to port 2. You make sure that your virtual machine is connected to the right port. And you enter the parameters. I do hope that the password was empty for this one. Oh yeah, it was. Okay, cool. So now it will get an IP address. Now we have to re-plug it to port 1, so a bit of fiddling there. And we'll actually use OpenWRT image to boot it via netboot and then do all the magic. So it works, it's doable, but it's slow, and turns out it's not that easy because there is an easier way. By the way, this presentation, I set it up so that I start with the demos, the fun demos. There will be more demos later on, but the fun demos in the beginning, and then in the end, you get to hear how it works. Okay. So there's OpenWRT now running on the device. And now when we switch back to port 2, it will actually try to fetch a script from the appliance, the virtual appliance, that will create the file and the devel login file, and of course upload the busybox for us. Sometimes it takes some time to connect, but usually in the end it always does. Okay, while it's happening, we will get back to that when it's done. So the problem with VirtualBox Appliance is that the current version works only with a very limited set of devices. So CPU has to be AR9344, and you have to have at least 2 Ethernet ports. It is in principle possible to overcome both of those obstacles, and we will probably do that in the future when the new way doesn't work anymore. Oh, I guess it's done. Yes, as we can see, everything is done. We got our busybox, we got our devel access, and that's it. And router is now rebooting. So that's basically it. It took like, I think, two minutes at least, right? It took some time. But now after we've done that, I think we can connect to it. Okay. And there we are, right? And we have a less, and everything works. But if I would try it on this device, for example, it would not work, because the CPU is different, and we couldn't be bothered to compile the damn kernel correctly. So the new way, it's a Bash and Python script combination. You don't need a virtual appliance. You can use any Linux device. It will work regardless of architecture, so it will work even on the more obscure versions of Router OS. It's very fast in comparison, and you can do remote jailbreaks. You don't actually have to have the device with you. You can jailbreak your device at home. By the way, if anyone has MikroTik routers they want jailbroken, I'm going to do a demo right now. You can bring it up, and I can jailbreak yours. Or if not, I will jailbreak this one. So minuses are those that it will not help you recover lost passwords, and it will probably get patched soon after this presentation. But for all versions, it will work. So, demo. Just plug into a port that's a local network port. We could plug on the internet port, but there's a firewall. It wouldn't connect. I connect my laptop, not the virtual appliance, to the network. Larger font, or is it good? Good? Font is good, yeah? Okay. So, We have exploit underscore full.sh. In a similar fashion as the virtual appliance, we need to specify the IP address. I would guess it's this one. The username and the password. Now, this will not allow you to get the password because, of course, it's doing it over the network. That would be a huge hack if we did that, right? And then it begins jailbreak process, and it's done. So now this device is jailbroken. And that's it. Now, it also reboots the device in order to reconnect it again and upload the BusyBox binary, and so that we can use LS and everything else. But jailbreak itself is that quick. If you take a look at the output here, you can already guess what's the vector here that we're using. OK, now while it finishes again, I will proceed with the presentation. Which are the tools? So the tools that we actually are presenting and that will be made available on GitHub after the presentation. Some of them already are available, by the way, but those have been there for a month or two. So for sourcing the package files from the internet, so that you don't have to actually dump a router or buy a router, you can actually get those files from the internet, of course. Very simple script. Let me demo those to you. All right, it's reconnected here. It's offering additional utilities, which is BusyBox. So for getting packages, we have this cute script. OK, so first of all, it ended here. We can connect to it, of course. If we type the username correctly. We have LS, and we have everything. Everything is working here. Right? Now, for getting NPKs, you can basically just go to their webpage and download them, but somehow they deny access to some of the old files. Basically, you can get about 20% of the versions only. So, of course, what I did is did a bit of Google hacking, or Google dorking, how it's called, and added some URLs, and it just tests all of them while I get. Of course, I can get malware that way quite easily, but well, it's not like I'm running it anyway. I'm just traversing them. So if you'd like to get some obscure version, like 6.3.4, let's hope it exists. It will go through all the URLs and try to download it, and as soon as it gets it, it will stop. OK, it didn't find it. OK, here, 633.2, for example, exists. And now we have it as a file. But it's packed. It's our proprietary format. So the other script that we can use is reverse NPK. We specify the package file. It depends on two things, unNPK script and unsquashfest script. And basically what we get is a folder with everything that's inside, the file system, basically. Here are all the fun binaries. They are quite small in size, so reversing them is not really a huge issue. OK, so next thing. the kernel patches. If we want to go the other way, and if we don't want to reverse their binaries, but if we want to look at the real source code, they use Linux, so it is GPL thingy, so they should be giving you out the kernel patches. Even though the license says that you have to contact them by post and send them $20 or $30, and then we'll send a CD out to you. In actuality, if you send them an email, they send you the link to download those patches, but those are quite old patches. Then again, there's one guy up on GitHub who managed to get new patches from them, and you can go there and you can work with those. And they also have config files for different architectures, which is super good because it allows you to more easily compile the kernel. Let's put it this way. An overview of the boot process of RouterOS. It's important to understand this so that you can, so you know where to put your custom executables if you want to achieve interoperability with some other tool. DNS mask, for example, it doesn't support it right now. So it's basically a Linux run process, right? We have kernel, it runs the init file, and then it runs a file called etc or rc start in case of RouterOS, which then goes to etc rcd rundy, and all the startup scripts are run. It's a standard process. Nova bin loader is the main executable that loads everything else. It also monitors all the other executables. So in case one of the executables dies, Nova bin loader will automatically restart it. There is also Watchdog. Watchdog executable is started by the loader executable, and it monitors the loader and everything else. So if the loader is unable to restart the process, either because it just fails or you actually killed the loader, Watchdog will detect it and reboot the router, which is cool compared to some other manufacturers. Now, the question, of course, is when you put your custom binary on, which folder do you put it in? Luckily for us, you can put them almost anywhere. If you take a look at this path variable, it adds the output of binary called path to the path. And what this binary does is it looks for specified paths in prefix directories. So if we go back one slide, this searches for /bin and /sbin directories. So if you make a directory anywhere in the file system that's called bin or sbin, it will be added to the path. Here we can see how that binary works. Now, this is a high-level overview of the RouterOS ecosystem. This slide has been a part of every presentation we've done so far, but there is a change. So, backup now is not only the access target, meaning the thing that we might, and that an attacker might want to get out of our system, but it's also the access vector, meaning it's a way for an attacker to get into the system, which is the exploit that that I showed at the beginning. Now, a quick overview of the NPK format itself. We've discussed this in more detail in other presentations, but since we are talking here about all the tools, I think it's important to include it in the overview. So this binary format, it consists of what you see here: the header in red, file size in green, then there are parts, and footer. Each part consists of the part type, which is of length short, and the payload size, which is long, or 4 bytes. And then the payload of the specified length. You can see the example there in the image. The orange part is the checksum, so you can't really go and create your own NPK files at this point, so you can't extend RouterOS that way. That's why we have to look at other options. We've identified at least 2 types of current NPKs in use. There's a package NPK and restriction NPK. And header and footer is different for those. In the previous slide, we saw a package NPK. Restriction NPK is used for resellers to limit the devices. For example, if I wanted to sell this router in the United States legally, I would need to install a restriction NPK that would limit the frequencies and the power used for the radios. And therefore, it's logical that restriction packages, after installed, are invisible. They don't show up to the user. One attack that we can do but I will not demo it because we haven't found any good use for it. But we can actually swap out the header and the footer to the different type. And we can install a classical package as a restriction, or we can install a restriction visibly as a classical package. It works, but it doesn't really produce anything interesting. Oh yeah, here's an example of a restriction being installed visibly as a classical package. These are all the part types that we've identified for NPK files. If we look closely, we can see that part types from 0A up to 0F are unused. My guess here is that's because the guy or girl responsible for actually creating new part types forgot that they were in hex and they were just going decimal. And that's why we don't have those 0A up to 0F. Subout_ref. That's an interesting access target, and that's why we looked at it and tried to find out what's inside. So subout_ref itself. Subout stands for support output. That's a file that their official support will ask you to send them in case you're having some difficulties that they want to debug. And that's how you create it. Now, .ref stands either for ridiculously intricate format, as we will see in the future slides, or router OS information file. There's actually no official documentation on either of those. What subout or ref means, those are just our guesses. Now, from outside, subout_ref looks as follows. It contains multiple router OS subout sections. It's an ASCII file, actually. And then we have something that looks like base 64. Well, if we try to decode it as base 64, we get garbage. What they did actually is they swapped bits around in the 3 bytes, in 3 sequential bytes. Here's a map that we found a couple years ago already, I think. And if we swap the bits around first and then do base 64 decoding, what we get for each section is an ASCII string that is the name of the section, a 0 byte, and then content that's compressed using zlib. So subout_ref decoder is actually online. It's available. It has been for some time already in the repository. Now, if we do decode it, here's what we see inside. There's your whole configuration. There's a /proc folder of your system, memory addresses, your log files, and much, much more. So let me show you 2 quick demos here. This is subout decoder. I think we have some files. Yeah, okay, here's a subout_ref file. And it decodes it. A folder is created, and we have all the files in there. These 5 files, 5 sections that begin with a dot are hidden sections, and those don't show up in their official tools that they make available to third parties. So if we take a look at this, there's a debug log, for example. Everything is in there, as I said. The other thing I want to show you is an exploit that we created using subout_ref encoder. And that they fixed very quickly. They fixed it, I think, I think it took them less than 24 hours to fix this. Very, very responsive. So what we see here, attacker is on top right, victim is on bottom left. Victim has been sent a bad subout_ref file by an attacker, and the victim is about to upload it in his account. And the attacker computer monitors a web server that expects a session cookie. As soon as it's uploaded, XSS gets executed and the attacker gets the session cookie. So if victim wouldn't press logout, the attacker gets access to the credit card information of the victim, all the license keys that the victim has paid for, and can, of course, order new devices, order new license keys. That's an attack we did in the middle of 2017. Now the config files. Configuration for your MikroTik device is stored in /rv/store as pairs of files. Each configuration set consists of an index and data. .idx is an index, .dat is data, and there's also Batman. IDX, the index format, consists of 3 entries per record. So that's 12 bytes here, because all of those are long. It's important to parse the IDX format too, because that format actually does not defragment itself automatically, meaning that that format may contain previous data, like old passwords, for example. That format is quite easy. So there's length of the section, and there's a record. It contains config ID and type. I will talk about it a bit more when I show you the tool to actually parse those files. Peculiarities of this format is that field IDs are shared with web. It's a binary format. You don't get like text saying IP address and then the IP address. You get an entry saying this is field number 1A5, and you have to understand that it contains the IP address. And the other interesting thing is that Winbox protocol, which is used for administering these devices from Windows machines, seems to be derived from that format, which suggests to us that maybe they are actually writing that file directly from Winbox, which is quite dangerous. So, demo of empty dot decoder. Empty dot decoder is a file that you can include in you can import in your Python projects, and will automatically deal with all the craziness of IDX and DAT files for you. Let me show you what I mean. So this is a script that uses the decoder. And it's quite easy to use, actually. We define some variables here, and this is where we invoke the decoder. We specify the DAT file and the index file, and we don't need anything else, basically. We can already print it. So even if I deleted all that, I could run this. And we get the IDs, and we get the values. But it's not too readable. So what we can do is we can, in an easy way, actually map the names to understandable labels. And we can add filters, which say that 0, for example, should be always no, and 1 should be yes. We can add filters that modify the content. Here's a function I defined. It will only print out a string on the screen if it actually contains only printable characters. And we can, for example, print some of the values in hex, and so on. If we run this now, we see that it is much more understandable now. And actually, we can get these mappings from .jg files. Let me show you what I mean. I will launch my browser. Now, Webfig contains some files that are used by the interface. Let me look up a name of the files quickly. Popped out of memory. Okay. So for example, there's a file called ntp dot, not here. Sorry, can't find them in the moment. I will show you a local copy then. But they are there, believe me. Okay, so this is how it looks. Those are JGA files. You can download them from your or anyone's router. You don't need a password to download them. And those are a bit similar to JSON format. And in there we have mappings between IDs and the names of the fields. So we can parse those and we can easily use them. Unfortunately, we're not including the JGA files in the repository, of course, because we don't own them. We don't have the right to do that. So the password, of course, is also inside the folder, user.dat and user IDs. And it's even encrypted. So it's actually hashed, salted, it's MD5. But actually, that's not the password, that's just the key. So they derive the key by salting and hashing your username and then applying MD5. So here is the algorithm. I want to let this sink in. So the key is derived from the username, which is usually admin, or you can just look at what a person is typing. And the password is the password stored in the file XOR the derived key, meaning that it's actually very, very much reversible. As soon as you get the files, you can easily deduce the password. Now, for this presentation, I tried and took a look at how did they derive that static part. Where did that static part come from? So I made a heat map of a keyboard. It looks like someone just took two hands and mashed it on the keyboard 2 or 3 times. And that's how we got it. Okay, so the password tool. For the password tool, let's get rid of all that. Now, for the password tool, we will use this. It's also on GitHub already. It's been there. Now, this Python file has a hard-coded path to the files, but obviously the one on GitHub doesn't. And this is how it looks. It basically outputs you in a neat format comparable to the one actually used by RouterOS, and you get the passwords, of course, decrypted. And everything else that's in there in that file. And it uses the same Python library that I showed you previously. Finally, last thing I want to talk about are backup files. It turns out we can actually use backup files to get into the system. It's not a vulnerability, it's just a bug, because we do need to know the username and the password of the admin user to be able to upload a crafted backup file. So we can't hack anyone with it, but we can liberate our own devices using that. And I already showed you the demo. So backup file layout is as follows. Backup file consists of a header of 4 bytes, depending on if it's a normal backup or encrypted backup. If it's encrypted backup, then everything else is encrypted, and it's like a backup inside a backup. But if it's not encrypted, then what follows is the length of the whole file, which is different than for all other files. They actually usually only include the length of the remainder of the file. Here, the length is of whole backup file, and then we have a bunch of records. We have path name, we have IDX contents, and .dat contents. And those go around as much as we like. Each of those records consists of the length 4 bytes, and binary data. So for example, if we wanted to save our user data in the backup, it would say 4 user, 5 the contents and some other lengths and the contents of the other file. What happens actually when the router loads the backup is this. It doesn't use hash for that, of course. It uses their own binary, but this is what happens. It creates all the required folders because, as you saw, there are subfolders employed. Then it writes IDX file to that location, and then it writes the dat file to that location. And that's basically it. Now, vulnerability lies within the fact that you can actually specify the file name however you want. So, for example, you can include some special or not so special characters. Let me show you what I mean. So we'll also be publishing decode backup.py today. It allows you to decode the backup files without uploading them. So it looks at all the parts of the backup file and creates them in a folder right here. Now, it does replace these with underscores so that you don't wreck your system, but the actual router doesn't. So that's how that part works. And luckily, it also allows devel login to be a folder, because we couldn't get it to be a file. We can't inject 0 bytes or anything like that in there. Right, and that's it. That's the presentation. All the tools and jailbreak are available there. The new jailbreak and new tools will be pushed shortly. As soon as I get back home, I can push them up. If you want to play around with the appliance, I showed you the latest one is available in that URL. It's already there. If you've forgotten your password, you can use that. Unfortunately, it only works on devices of special CPU, specific CPU. So yeah, I'm not sure if we have time for questions, but that's all from me. Thank you so much.